Hi, this is Professor David Farina. In today's video, we're going to be talking about Jovian moons, rings, and Plutoids, in particular planetary rings. Let's get started. So, of course, the most iconic of the planets with rings is Saturn. So much of our discussion today will be about Saturn, but we're going to be discussing all planetary systems with rings here in our solar system. Now, as you can see here, these are the rings of the planet Saturn, and you can see they are labeled A, B, and C, with A being the farthest out, B ring being the second one in, and C ring being the one that is closest. All of these rings are part of a ring system, and rings are not permanent features of any planet. This means that the rings must be constantly replenished by things like asteroids and meteorites coming in, or meteoroids coming in too close, and they are torn apart by something called a tidal force. And we'll talk more about that in a slide coming up. So what do these rings look like if you were to come close to them? In fact, they would be moving around the planets very, very quickly, but they move at very small relative velocities compared to each other. So if you were able to match the speed of the ring system, kind of like high-speed cars driving on the highway, so long as their speeds are the same or very similar, they can all travel together. So you could get close in and you could kind of float around and move along with the particles. To give you a sense of scale, many of the ring particles, most of the ring particles, are about the size of smoke, whereas the largest of these particles are about the size of a school bus or so. The rings, although very large, are also very thin, as this image shows, and you can see some of the moons of these various moons of Saturn from this perspective as well. And there are resonant frequencies, and by resonant frequencies I mean ratios between the orbital periods of these moons. So in these little simulation here, you can see that the middle dot is going around 3 times for every 2 times this orange dot goes around. So let's watch this again. Start with the middle. We'll wait till they match up. Here we go. 1, 2, and 3 of the middle dot. And we'll count the next one. We'll count the orange one now. 1 and 2 of the outer moon. So when we have an orbital resonance like this, we end up with gravitational interaction, which can cause the shepherding of ring particles, which are allowing for things like divisions, specifically the Cassini division. Now, there are many more rings than just the A, B, and C ring, and you'll notice that they're not in order. The reason for this has to do with their discovery. So the A, B, and C ring were discovered, and then later rings were discovered and assigned letters. And they kept the original naming conventions because more and more rings were being found. Now, the way we can see Saturn's rings has to depend on where Saturn is in its orbit. For example, in 2002, Saturn would show Earth in our orbit its southern pole. And that's similar to this image right here. By 2009, we saw the edge-on version of Saturn. Now, moving towards 2017, we saw the North Pole, which is not represented in this image. And by 2024, we're going to see an edge-on version of Saturn once again. So when we go around in Earth's orbit, you'll notice we're always on this place around the sun that sees a particular aspect of Saturn and its ring system. Now, I said earlier that the ring systems are not permanent features of any planet. And that means that they must be replenished over time. So here we have a satellite coming too close to the planet itself. This point right here is called the Roche limit. And as we have time move forward, notice that the satellite here now has gotten closer. It's being stretched by gravity. It gets even closer. It's stretched even more by gravity. Eventually, the amount of gravitational tidal forcing is too much, and the moon or satellite is broken up into ring particles, as seen at the bottom here. Now, as I said earlier, not just Saturn has rings. In fact, all of the Jovian moons here in our solar system have rings of some sort, and this is a really nice graphic that shows you the planet's surface being at the very bottom of this graph. Here's the ring around Jupiter. Here are the many rings of Saturn. Here are the many rings of Uranus and the many rings of Neptune. Now, some of Saturn's rings are known as shepherd moons, and what this means is that we are shepherding particles, as we said earlier. We're going to have an interaction between Pandora, in this case, and the F ring. Now, you can see in this little graphic here, this GIF, that we have a moon moving through ring particles and causing these tidal waves through the ring particles themselves. Jupiter is also found to have rings, as you can see in this image. They're not visible through a normal amateur telescope, but we have been able to image them with other larger telescopes. Here's Uranus with its 9 rings. The epsilon ring is highlighted here and zoomed in upon. You can see it's made up of a bunch of other little smaller ring particles. And here's a quick simulation to show you how these ring particles are discovered. So usually they're dark, and as a result, all they can do is really block the light from a background star, indicated here by this yellow dot. And what we're going to do is we're going to set time forward, and it's going to have this yellow dot move in this direction. As that happens, this red dot here is going to indicate the location over time of that star, and you're going to see at the different places here we have the planetary rings are going to blink out this background starlight being in the foreground. So let's watch. 1, 2, here's the gamma ring, and the epsilon, notice how deep it is. It's the deepest one, and it's also the brightest line here. So we can see that occultations of background stars are a wonderful way to detect ring systems. Here are some of the rings of Neptune as well. We have 2 outermost rings. I'm sorry, this is Uranus. My fault here. I have this as Neptune, and this is Uranus. 2 outermost rings of Uranus are also most recently detected as well. Uranus also has some shepherd moons here that are guiding this epsilon ring in place. And now we're finally to Neptune. Okay, so Neptune also has rings, and they're once again made of dark material, and they're being constantly resupplied by meteorite impacts on the moons themselves. So thanks for watching today's video on Jovian moons, rings, and Plutoids, specifically planetary rings. I hope you liked this video. If you did, please click the like button. If you would like to learn more, please click subscribe. And if you'd like to get a notification each time I make a video, please click the bell at the bottom. Thanks a lot, and have a great rest of your day.